All right, friends, it's your boy, Mr. Shagney, coming at you with another video today on interpreting inequalities. So today in class, we're going to be continuing looking and graphing inequalities. And so the first activity we're going to do is we're just going to do a true or false activity using some things that you should know how to do. So the first the first number says 3. You have 3 out here, then you have 12 and 12 plus 5 out here, and then it's saying, does this equal the same thing? So if you solve this, right, I'm going to distribute this 3, and if I distribute that 3, that gives me 36 plus 3 times 5, which is 15, and I want to know if that's the same thing as doing this. Is this what I just did? 36 times 15. So over here I'm writing 36 plus 15. Over here there's a multiplication symbol. So this equation is false because the sign between the numbers is different. So you're not performing the same operation here, which is why you're going to get a different answer. What I did here is I used the distributive property, and so the distributive property states that you can distribute this 3 by multiplying it by the first number. So 3 times 12 is 36, then you write the addition, and then 3 times 5 is 15. You would normally see it like this. The parentheses indicate that you perform that first, but the problem here with this problem is that multiplication sign. So that, to me, that tells me that this problem is false because they are not going to add up. And if I were to perform the math for this is 51 on this side, and then 36 times 15, that's 6. So 51 and 540 are not equivalent, so that's why that one does not work. This one is saying 1/3 times 3/4 is the same thing as saying 3/4 times 2/6. Now, for this problem, what I'm going to do is I'm going to look at this. Can I simplify 2/6? And in my mind, I can, because 2 and 6 are both divisible by 2, so I'm going to divide them both by 2. That gives 2 divided by 2 is 1, 6 divided by 2 is 3. So really it reads 1/3 times 3/4 is the same as 3/4 times 1/3, or 2/6. These are true. True because swapping numbers in multiplication results in the same answer. All right, the next one says 2 times 1.5 times 12 is the same as 4 times 7/500 times 6. Now thinking about this, right, so I'm gonna use the math to solve this. So first in multiplication, I can multiply what I want first. So I'm gonna do 12 times 2. 12 times 2 is 24, and then I still have times 1.5. Over here, I'm gonna do 6 times 4, and that gives me 24 times 7/500. So when I get to this step, right, when I see that I have 24 times 1.5 on one side and then 24 times 7/500, will it result in the same answer? And so the answer to that is no. So this is also false because 24 is being multiplied by 2 different I'm looking for a word here. 2 different numbers, or 2 separate factors. Right? So these obviously are not equivalent because 7/500 is not equivalent to 1.5. So hopefully you can see that. So the whole point of this is to really think through, like, mathematically, do you understand the distributive property? Can you Can you simplify fractions? And then can you understand that you can move, right? So this problem, so this is distributive property. This is the property that states that you can move numbers and you'll see the same outcome. I also use that property here where you can multiply any number out of order and you're still going to get the same answer. As long as it's all multiplication, you can do that. All right, so hopefully that made some sense. So the next activity we're going to be looking at today is we're going to be looking at a basketball game, and we're going to be looking at this through the lens of Nick, who's going to score some points in the basketball game. N is going to represent the points that he scores, and so what we need to do is we need to read each question and we need to truly think about like what it means in this situation. So for this, it says, what does 15 is less, or what does 15 is less than n mean in the context of the basketball game? Well, if n represents the points that Nick scored, then we know that his points that he scored are greater than 15. So in this, Nick scored more than 15 points. Right? What does n, the amount of points that Nick scored is less than 25, meaning in the context of a basketball game? It means that Nick scored less than 25 points. It says draw two number lines to represent the solutions to the two inequalities. So I'm going to draw a number line, right? This is 0. Can you score less than 0 points in a basketball game? No, I didn't know that's not how basketball works in real life, so you can't have a negative score. So I'm going to count by 5s. And for the first one, he scored more than 15, but it does not include 15, so I'm going to put my open circle, and I'm going to take it to the 25. So what I'm going to do is I'm going to make one inequality here. And I'm going to take it to the 25 and put another open circle there, so you can see that his range of points is between 15 and 25. So he scored somewhere in that. Name a possible value. So what is a possible number that's between 15 and 25? So when we draw an inequality, we're really thinking about what are the possible solutions to this inequality. So a number that's possible here is that Nick scored 16 points. That's a possible solution. The next thing says name a possible value for n that is a solution to his score being greater than 15, but not a solution to n is less than 25. So you can see that I wrote this twice here. That's a boo-boo on my part again. So you're looking for a number that's greater than 15, but not a solution that's less than 25. So a number that's greater than 15, but not less than 25 is 26. So this is not a solution because yes, that is greater than 15, but it's not less than 25. So 26 is a solution that works. You can also use 27, 28, 29, anything that's not going to make the second one true. This question here says, can -8 be a solution to n in this context? Well, if we're playing basketball, right, you cannot score negative points. Like, you don't go backwards because you foul people. So no. -8 is not a solution in this context because you cannot score negative points. All right? And then for our last activity, we're going to be looking at unbalanced hangers. And basically what this is that when you think about equations and inequalities, you need to think about them as like a balance beam, or if you've ever played with the thing where you put the blocks in on one side, the pan balance, and so that's what I was looking for, and it wasn't coming to me right away. So the pan balance, like, that's exactly what we're doing with equations and inequalities in mathematics. So we're going to read these and walk through these. So Sophie says that the weight of one circle is greater than the weight of one pentagon, right? And so you can see here that the circle is dragging the pentagon down, which means that the circle weighs more than that pentagon. So it says, write an inequality to represent her statement. Let P be the weight of one pentagon and C be the weight of one circle. So P is saying that the pentagon is less than, right, the circle. That's the inequality. The pentagon is less than the circle. It says a circle weighs 12 ounces. Use this information to write another inequality to represent the relationships among the weights. Then describe what this inequality means in this context. Well, what I'm going to do is it told me, so I'm going to rewrite P is less than 12. And what that means is that one pentagon weighs less than 12 ounces. Okay? The next one, here's another diagram of an unbalanced hanger. Write an inequality to represent the relationship of the weights. Let P be the weight of one pentagon and S be the weight of one square. Well, in this situation, the pentagon is weighing the square down. So in this situation, right, the pentagon is greater than the square, right? And so you could, the pentagon is greater than the square. So one pentagon weighs 8 ounces, so I'm going to take what I just wrote. I'm going to take what I just wrote and put 8 in for pentagon. So 8 is greater than S. This means, my bad, my brain stopped working. This means that a square weighs less than 8 ounces. Graph the solutions to this inequality on a number line. So 0, I'm going to count by 2s, 2, 4, 6, 8. If square has to be less than, right, it does not include that value, so anything that's less than that. We could also say, so we know that, we can also write it like this, S is less than 8, 8 is greater than S. For this one here, you could say, 12 is greater than P. It's all up to how you want to write it. I like writing it, ways, but it should still make sense in your graph and your inequality statement. They should still make sense. They should have some sort of connection. So this one, number 3, says, based on your work so far, you can tell a relationship between the weight of a square and the weight of a circle. If so, write an inequality to represent this relationship. If not, write an inequality. If not, explain your reasoning. So we know that the circle, so we have 2 things so far. So we know that a pentagon is less than a circle and that a pentagon is greater than a square. Using this information, we know that a circle is greater than square, right? It has a greater weight. So that's what you should be able to say. The square weighs less than a pentagon. Since the square weighs less than a pentagon, then it should also weigh less than a circle. Number 4 says, this is another diagram of an unbalanced hanger. Trask writes the following inequality. C plus P is less than S. Do you agree with his inequality? Do you agree with his inequality? Explain your reasoning. C plus P, so circle plus pentagon, is less than the square, is what he's saying. So no, the circle and the pentagon are greater than the weight of 1 square. And this statement says the square is greater than the circle plus the pentagon. Okay, Annie looks at another diagram of unbalanced hanger and writes S plus C, so square plus circle is greater than 2t, where t represents the weight of 1 triangle. Draw a sketch of the diagram. So she's saying that a square, so I'm going to draw a square, I'm going to attach it to a circle, and that weight, so it should be weighing the other down, so kind of like this. And 2 triangles, so I want 2, and I want to show that mine's kind of lopsided, but really that, this plus this is greater than that is really what the goal is for that activity. All right, I know that took me some time. I am going to walk through the exit ticket because I think it's important for us to understand the exit ticket as a unit, and then I'll be moving on to the homework in the next video. So Phoebe says the inequalities H is greater than 150 and H is less than 160. Describe her height. So H is referring to her height in centimeters. What do the inequalities tell us about her height? Well, this tells us that Phoebe's height is between 150 and 160 centimeters. That's what it tells us. So it says Marshall notices that he is a little taller than Phoebe, but is shorter than their math teacher, who is 164 centimeters tall. Write 2 inequalities to describe Marshall's height. Let A be Marshall's height in centimeters. So we know that Marshall is a little taller than Phoebe, but we also know that he's shorter than the math teacher. So Marshall is A. A we know is less than 164. He can't be taller than that. We also know that Marshall is greater than the height of Phoebe, and we used H in the previous one. So this is what we do know, right? So he's greater than that, and so what I'm going to say about that is that we know that he should be greater than 160, because Phoebe technically could be 159, but she's less than that, so he could equal 160. So he could be greater than or equal to 160. Those are things that we do know. Select all heights that could be Marshall's height in centimeters. If you get stuck, consider drawing a number line. Well, he can't be 150 because that's not greater than 160. He can't be 154 and 4/10 because, right, like he has to be a little taller than Phoebe. And if Phoebe is 159, the possibility to me, right, does not make sense that he would be shorter than her because it says that he is a little taller in the statement. 160, he could be 160 because that is going to be taller because I did say equal to. He can also be 162 and a half, but he cannot be 164 because he should be shorter than that. And so that's what we're looking at today in class. So I look forward to seeing you there.